Problem 6. In the plane below, we have 3 unit squares that are shaded, and we're trying to find the number of squares I must additionally shade in order for the resulting figure to have 2 lines of symmetry. So 2 lines of symmetry, you can take it either way. You can either take it, such as up and down, or a diagonal, cross across. But we're going to do the up and down version, because if you were to do a diagonal, notice that it's 4 by 5. So that means the slope will be 4 over 5, which is not a whole number. So it will not pass through every single point like that very neatly. So we have squares that are getting cut off like that, and we don't want to deal with that. So we're just going to deal with the straight up and down axis of symmetry for convenience. So in order for it to be symmetrical, it has to be right in the center. So this line and this line. Obviously, this square right here has to have a matching pair right here. If you're to flip it across, let's call it y, let's call it x, the y-axis, same for the x, right? And then this square right here must also have a corresponding square within the reflection of the x-axis. The same goes for this square. Has to go here, has to go here, has to go here. So notice, every single square must have a corresponding square across the 4 quadrants that are created. The same goes for this square right here, but the only difference is that it doesn't occupy one quadrant specifically. It occupies 2 quadrants at once. Therefore, it only needs to be reflected across the x-axis to get this square right here. Counting it up, you get your answer, which is 1, 2, 3, 4, 5, 6, 7, bringing you to answer choice D.